multiplication could be like no common differential ratio, or what is the ratio, or what is the difference, right? Alright, are there any problems that you guys got wrong on the evens that we could peek at real fast just to use as a review of section 6.6 that we haven't done for quite a while? Andrew?
4 and 8.
4 and 8. Anything else that anybody might have gotten wrong? Yeah. Oh, because you couldn't find it. Yeah. Yeah. You can always turn in homework for late quickly. It's okay. Alright, let's go peek at number 4 and 8 really fast. And for some of you guys, you might have gotten it right. It's just remembering what the questions were and what was going on in section 6.6. And for others of you guys, you might have gotten it wrong also. So, for number 4 and 8. Hey, kiddos. It's a Monday. I don't know why that means that you should be disrespectful. I know it's been disorganized at the beginning of class. That makes sense. That makes sense. But don't worry, I'm here. We're good. Let's do this thing called math. Yeah? Alright. So, we're trying to do number 4 and 8. And if you said no, too bad, so sad. The things are much easier to do when you have a happy heart, or at least you're trying to have a good attitude. Right away, we have vocab. Common ratio and geometric. So we need to remember a few things in section 6.6, because that's what we're doing today. Common ratio and geometric. Okay, geometric sequence. What'd you learn first? Arithmetic or geometry?
Geometry.
So geometry is the harder one. So is it multiplying or addition?
Addition.
Oh, it's the harder. Yeah, so that should go with arithmetic. See it? See it? The earlier ones. So addition, just think AA, right? Addition and arithmetic. There you go, that works. Addition and arithmetic, and then, okay, geometry has the multiplying. So common ratio, we're looking for the multiplication pattern, okay? Multiplication pattern, I think I know why Andrew found 4 and 8 harder than the others. Now, some of these were hard too, to be honest. But this one was pretty easy. Jerry, stop, Sean, hang in there. 4 times 3 times 3 times 3. Times 3 was a pretty easy pattern. But this one is not, well, it is times, but it's kind of closer to division, right? Kind of closer to division. So I could say dividing by 6, but technically that's not what the answer key shows, is it? Did it show on number 4 division by 6?
Yes.
Well, kind of, but that's not what the common ratio would have been. I would have taken points off on your test or quiz. Because even though division by 6 is right as far as the pattern, the common ratio is the number that you multiply by. So to divide by 6, you multiply by 1/6. You see it? To divide by 6, you multiply by 1/6. So I know it's really weird. But guys, the division is there. You just can't literally say it. Because when you say R equals, which is technically what you're supposed to be doing in these. R equals, you can't say R equals divide 6. That's not a proper math expression. R equals divide? No. So you have to think, okay, what's multiplying? And since there's division, we think 1 over whatever it is you're dividing by. Now, I think there's division going on down here too. But, do any of you guys get overwhelmed when the numbers get big?
No.
I know, I do. And a lot of you guys are really tied to your calculators. So if this is tricky, why not go down here and ask yourself, well, I know it's multiplication. More specifically, if it's going down, it's division. So what would you divide 18 by to get 6? Yeah. But you notice that the signs are switching, right? Now, once again, can I say R is equal to divide by -3?
Yeah.
No, I can't say equals divide. Come on. That's improper notation. So how do we put the R that shows the division? Yeah. So anytime you see division in a geometric sequence, you want to put 1 over, make sure you check the sign. Negatives make it pop back and forth, negative, positive, negative, positive. But 1 over means divide, okay? So if you're seeing a division by -3, if you're seeing a division by 6, this is a really good question, Andrew. Thanks for bringing it up. If you're seeing division, R is going to be 1 over. Cool? Give me a thumbs up if you're like, okay, I think I can kind of remember that. Okay. And if you don't think you can kind of remember it, shouldn't you be like highlighting or with a colored pen, marking in your homework and being like, oh, you should pay attention to these because they're tricky, especially with the quiz on Friday and a test coming next week early. just on section 6.5, 6.6, and 6.7, and we're almost done. Okay, thanks, Andrew, for those questions. Now, hold on. With his questions on 4 and 8, we were able to review geometric sequences, but Trey, what's the other type of sequence? Arithmetic, and it's not talking about multiplication patterns, it's talking about addition patterns. Can you guys, just looking quick, maybe at your homework or maybe just up here, can you find one of these that was arithmetic just to help us review the vocab?
9.
9? Because number 9, what are you doing?
Adding 8.
You're adding 8 every time. You're going up, but you're going up a specific way. You can't just say going up. You're going up by addition, right? Since it's addition, that would be an arithmetic sequence and question. What would we call that 8? What's the vocab for his common pattern? Not common ratio.
Common difference.
Oh, yeah.
So this would be D equals 8. Okay? So we have arithmetic, which is adding, and a common difference. Arithmetic, which is adding, and a common difference. It's kind of like they can't spell add. A-A-D. Kind of works though. Maybe we could try to make something out of it. Arithmetic, adding, common difference. And then geometric, well, that one's not very fun. You have GMR. But anyway, you have geometric multiplication ratio or arithmetic adding difference. Okay, that was the beginning of section 6.6, which we are going to move on from in our notes right now as we go to the end of section 6.6. Tomorrow's going to be a worksheet as we do some homework, practice, etc. But I want you guys right now, maybe there's at least one calculator per group. Number 19 had these exact same directions. You just didn't learn how to graph yet on Thursday. So I want you guys in your groups to find for me. Ready? To find for me the next 3 terms. I'm going to write blanks for each of these. To find for me the next 3 terms. And to tell me what R equals, because this is a geometric sequence. Now guys, this is super sad. I am so sorry. I just heard some of you put your homework away. I was going to have you just have it open on your desk so I can come grade it real quick. So keep the homework open on the desk. Just fold back the spiral. And I want you guys to do your groups. At least one calculator per group. And if you don't have one, come grab a calculator. Find me the next 3 terms and answer. What is the common ratio?
I didn't. Guys, you should be in your composition books, not your spirals. This is notes.
I got 81 plus 43.
The next 3.
Time period. You guys can I'm smart.
You need it.
So you're not going to do it.
So you just did the answer. Yeah, it makes it
Good job, Melanie.
How can it smell like really bad? No, cross that out. 729. It really
Let's go
Which is all
Have you figured out your common ratio on number 4? Good. And so once you figure out the pattern is times 3 times 3 times 3, then you should have done 27 times 3. What is 27 times 3? 81. Nice. And then you were supposed to do 81 times 3. And that would be 243. Whoop, this is getting big. And then 729. Alright, nicely done, nicely done. However, before we go to number 5, we're going to actually do this next piece. Now, this next piece is really important for what we're doing today. The next piece says to graph. So we weren't ready on Thursday, but we're ready now. This is geometric. We have a common ratio, 3. You guys found the pattern, times 3 times 3. You even continued it, which is great. But here's the struggle. How do we graph it? Because I thought when we graphed, don't we normally need an x and a y? Right? But don't we know? Because we need to go over and up, or back and up, or back and down, or over and down. We need an x and a y, and we just have like a random sequence, vocab sequence of numbers. I think I'm supposed to graph all of them, but how do I graph them if I don't? Okay. Let me show you something. Leave it. Yeah, kind of. Levi's saying that we need to make something for x, and that's actually really good. I want you guys to realize that all of these are really your y's. All of these are really your y's. So when you're graphing, the sequence, hey guys, you don't know how to do this, so you should be doing this, okay? I've given you time to talk, to collaborate, to ask questions, even check in on each other this morning. Now it's time for class. So the sequence, that's this pattern of numbers. Those are going to be your y values. So then, as Levi said, we got to figure out what to do for the x. I'm going to say the position of the numbers are going to be your x values. Now, position. You guys know positions if you've ever been on a sports team, right? There are positions on a team. True? Now, I know basketball better than anything else because I played in high school. We would talk about the 1s, the 2s, the 3s, the 4s, the 5s. Now, maybe you guys call them like the guards and the centers and the post players, whatever. But we wouldn't actually number them. The 1s, 2s, 3s, like 1 was the point guard, 2 was the strong side guard, right? Then we had the weak side guard was 3, then 4 and 5, it was down at the post. I don't know if you guys have ever been on a team where they actually numbered positions, but these sequences, or these numbers in the sequence are in positions too. So for instance, for this one, for number 4, who's in the first position?
1.
Yeah. Who's in the second position?
2, 3.
Yeah, exactly. So if we were trying to find our x's, now the book is going to actually call these x's n's, but for right now, just to like prove a point, this is going to be your sequence. I'm going to do SEQ for sequence on the y's, and this is going to be the position on the x. So when you are graphing a sequence, the sequence is going to go, the actual numbers in the sequence is going to go on the y, and then the position is going to go on the x. So let me show you guys how that works. Let me get rid of this x real quick. I'm just going to make him small, or actually I can even make him big. Let's go ahead and copy him because we need to do 2 of these guys. Now if you guys notice, these numbers are huge, so we're going to have to totally change our units, or else we're going to get kind of messed up as far as where to put them. This one doesn't go super high, but it is a really good idea if you're graphing to go ahead and see the highest number. So the highest I see is 700. Oh, stink. So I'm going to go by hundreds, which is really messy and really confusing, but that's okay. I'm going to go 7, so 1, 2, 3, 4, 5, 6, 7. There we go. So we're going by hundreds. 700 is there at the top, 100 is down here at the bottom. Okay? But then how many numbers do I have? 1, 2, 3, 4, 5, 6, 7. I have 7. So I'm going to go 1, 2, 3, 4, 5, 6, 7. First position, second position, third position, fourth position, fifth, sixth, seventh. Let me see if I can zoom in a bit because this is getting kind of messy. There we go. Okay. So who did you guys say was in the first position?
1.
Got it. So I'm going to go ahead and graph the point 1, 1 because that's my first position, right? And then I have my second. Oh, my marker is way too big. I know. Working out the kinks. Here we go. Let's try this. Is this better? I have my first position, my second, my third, my fourth, my fifth, my sixth, and my seventh. So ready? When I get down here to the graph, when I go to my first position, x is 1, and I go to 1. Well, hold on. If this is going by 100, I have some major issues, right? Because how low is this guy going to go?
Very low.
Yeah, if this is 100, see if I can get rid of him. Yeah, just went. There we go. If that's 100, it's going to be really low. So super, super low. Hey, how about 3? Isn't that going to be just a little bit higher?
Yes.
Stink. 9, just a little bit higher. Yikes. 27, just a little higher. 81, just a little higher. But then all of a sudden I'm at 243. Okay, now I'm at 250-ish. And then I'm at 729. I'm way up here. Okay, what does this look like? Yeah, totally. Now, wait a minute. Hold on. Way back then, we actually connected these, right?
Yeah.
Okay, but here's the problem. In this section, we're not talking about all the in-betweens, so we're not going to connect, which is really weird. Usually, we're used to connecting all of these and having it swoop up, but instead, we're just going to leave it as points. You actually call it, if you want the snazzy math term, discrete graphs, where it's just points, no connections, because guys, is there ever a 1.5 position?
No.
Sean, is there ever a 1.5 position? A 1.25 position? A 2.07 position? No. Which means I can't connect because there is nothing between 1 and 2. There is nothing between first and second. I can't connect or else I'd be having all these weird random decimal positions that make no sense. So, what are we going to do on this guy when I come way over here? If I can come way over here. I have to graph him. You guys were trying to finish the pattern. Did you figure out what the pattern was? What's going on every time? It's going down, but by division, so we multiply? Good. By 1 over 5. But we're dividing by 5 is the pattern. So R would be 1 over, like we saw in homework with Andrew's questions. So if we divide by 5, you guys get 4? Now, the next one was weird, because if you used your calculator, you might not have seen that it was 4/5 or 0.8. It is 0.8. But do you see how I just divided by 5?
Yeah.
Or multiplied by 1/5? What would happen if I multiplied by 1/5 again? I would get 4/25,
Whoa.
which is a nasty decimal. Do you think we get the nasty decimal? 0.66. Stop speaking about it. Oh, 16. 0.66, I think, is 2/3. Okay, got it. Thanks, Sam. And this one was 0.8. But we need to graph these guys. So remind me real quick. We have we have 1, 2, 3, 4, 5, 6, 7 again. So I can go 1, 2, 3, 4, 5, 6, 7. Those are my positions, right? Oh, but hold on. I need to graph it. 2,500. Thanks. Well, I'm going to make this Y a bit bigger just because it got really squishy last time. So let me go ahead and make this a bit higher. We'll put 2,500 at the very top. What do you guys think? Go by 500s?
Yeah.
It's not great, but all right. So we'll go 5 and then 1,000 and then 15 and then 2,000. So there's our 500. Too much work. We're just putting dashes.
And line.
And lines. Now hold on. Let me get this to be thin again. There we go. Okay. So what's in my first position again? When x equals 1, my first position goes with 2,500, right? My second position is going to go with 500. That was a big drop. My third position is 100. Man, that's only like 150. You guys see how it's just going to start to get so tiny we cannot even see it? So hard to show. So you guys don't necessarily have to, if you're fitting in 2,500, it's going to be really hard to show 0.16. So what I do is I just kind of put it barely above the axis. The best thing we can do. But once again, are we supposed to connect it? No, because it makes no sense if the x's are the positions. Levi, what you're thinking of the 0, the 1, the 2, sometimes in sequences you do start at 0, but our book just starts at 1 because it's easier to think first position 1. So we're going to kind of ignore the 0 right now. In higher math, sometimes they totally do bring in a 0th position. It has to do with physics and how physics, like at the beginning of something, time is 0, time past is 0, and that's why they do that. But for us, we're not really doing physics problems, so it's okay. So guys, let's see. In homework, we're having you guys start at number 15, right? Let's go check out number 15 really fast. I'm on the wrong page. No wonder it doesn't make sense. Why did I skip? Maybe you guys noticed and maybe you didn't. Why did I skip 15, 16, 17, and 18 on Friday?
Because they're all
They're graphs, and we haven't done it yet. But now does it make sense why none of them are connected? They're sequences. They're just like number, comma, first, second, third. So couldn't you technically, you guys didn't do too bad with these. Couldn't you technically rewrite each of these graphs to be looking like that? Now, I'm going to actually do one of your homework problems. Let's do an even, because those are tricky, because you can't grade them. Can we just peek at number 16 real fast? Can you guys help me look at this graph and help me write what the sequence was, where this came from? What was the first number in the sequence? 4? How did they do that? They're totally wrong. How'd they do it? They looked at the x-axis and they said, hey, when x is 1, that's the first. That's the first. So what would be the second? 11. What would be the third? Is it easier for your brains to look at it like this than like that? It is for me. So you can take any of these graphs and you can write them as a sequence and then ask yourselves, does this look like arithmetic, geometric, or neither? What do you see? Yeah. Because my guys that are looking, did you see the +7 and then +5 and then +3? There's a pattern. It's a pattern of adding decreasing odds. If you're like 7, 5, 3, the next one would be 1, and then -1. There's a pattern, but is it a constant, the same number every time? No. You can try multiplying, but so therefore this one's a neither. But do you guys also notice that this doesn't have like a nice swoop up or down, and it's not a line? You're going to notice, just a quick hint, that arithmetic ones look linear because it's adding or subtracting. Geometric will look exponential, but either with an increasing or a decreasing. Now remember, we're not connecting them, but that's just what the patterns will look like. So for instance, can you guys tell what sequence this one probably is?
Yes.
Linear, which means?
Arithmetic.
So it must be like a plus pattern. This one looks, kind of looks like a swoop, I think, maybe.
Always.
I might have to be careful on him, but I think he might be one of these guys, which means exponential geometric. And this one's definitely a swoop. So therefore, geometric, he's this guy. But do you guys see? Make a sequence. And then check it out. But that's not all of homework. Hold on. Homework picks back up in number 20. What's going on over here? Oh, wait. You guys had number 19, didn't you? In the last homework? So what do you think I'm not going to cross out this time in the directions? Okay, so you're going to write the next three. Find the pattern, the common ratio. So I think these are all geometric. You're going to continue the sequence, and then you're going to graph them. And then, what's the one thing we haven't learned yet? You guys check out the end of homework real fast? I think this is important. It's the last thing we need to learn for section 6.6. Write an equation for the nth term of the geometric sequence, then find a sub 6. What is this notation? We have not learned this notation. We need to go back to our notes and say, what on earth is going? Hold on. Let's get back to this view. What's going on? Oh, you guys see why this is the last piece of notes? We've talked about vocab. What is arithmetic? What is geometric? What's sequences? What is the common ratio, common difference? We've talked about graphing them today. How do we graph them? Don't connect them. First position, second position, third position. But now, we have to put some snazzy notation to all the stuff we've been talking about. How do we do that? We make an equation using this form. Because we've done equations in our notes before. Pick it up. Calm it down. It's the last thing we need to learn. Some of you don't pay attention to equations, but this one's an important one. Like some of the ones were last chapter with exponential functions. And this is super important for the end of homework. But if you can figure out, if we can together talk about this equation and where it comes from, it's really not that hard. But you need to write it in your notes so you can use it for homework in a way that makes sense. The homework that we just graded was homework number 12, right guys?
Yeah.
Okay. Let me make sure I have that. Okay. In any equation, the most important thing that we need to start with is who are all the players, who are all the pieces. Okay? So if you want to think about it, it's kind of like we're looking at some sort of weird picture. We're trying to figure out what we're looking at. So let me go ahead and label each of these in a way that kind of makes sense based on what we've talked about today. You ready? This one, right here. Hey, crazies. You're not crazy, but you are noisy. Maybe a little crazy sometimes. This one is going to be your first term. First position. The initial guy, the important guy. In this one, it's 1. In other ones, you guys know it's not always 1, right? The one we just looked at, 4, was the first one. So a sub 1 is the first term. Okay, well, hold on. Wait a minute, then. I see 1. If it was a sub 2, it would be the second term. A sub 3 would be the third term. I'm saying sub because have you guys ever seen in like Microsoft Word, there's subscripts and superscripts? If I have something like x squared, I'll have learned it in English at some point, sub versus super. Sub is below, super is above. This is what we would call a superscript. That's even something when you look in like Microsoft Word and you hit the like little exponent button, superscript. Whereas if I were to put something down here, it's called a subscript. Kind of like a sub goes underwater. Superman flies up. I don't know, Superman probably flies all over. But anyway. This is just describing who he is. A. Which A? The first one. So who's A? A must actually stand for a term. Maybe we should read that. This little A guy stands for a term of the sequence. So A means a term of the sequence. So A sub 1 is the first term of the sequence. Well, then what does this A sub n guy stand for? Now, why do they put a TH at the end? Well, first has an ST, second has an ND, third has an RD, but then fourth, fifth, sixth, seventh. What's everything after third? THs, yeah. So they just put TH because that's the most common one out of all of them. So when we're trying to look for A sub n, he's our nth term. That can totally change based on what they want. He's our nth term formula. So we have our first term. We're always going to know him. Our nth term, we're going to be looking for him. Well then, oh, nth term. Well, maybe it's second, or maybe it's third, or maybe it's fourth. N is the position. Because whoever's here is the position, like here's the first position, this is the unknown position. N stands for the position. So when we go down here to our example, let's see if we can make an A sub n formula, which is exactly what, if you guys need to remember, it's exactly what this is asking. Write an equation for the nth term and then find A sub 6. So if we were to do something similar in our example, we would want to find the equation for the nth term and then find A sub 6. It's as easy as setting up the formula and saying, okay, I have A sub n is equal to, my first term you guys already told me is 1, right? Times, do I just write R? This is the one guy we didn't talk about, but we already knew. Who's R?
3.
Good, the common ratio. Guys, what's the common ratio for this one down here?
3.
R equals 3. So I'm going to plug in times 3. So I have my first term times my R. And then all I have to do is check it. Write n minus 1. So if I was to write it as a snazzy way, the nice thing is that 1 times doesn't actually change anything. But that is my equation for the nth term. So if I were to finish the second part of homework in these problems, find A sub 6, I'm saying what position am I looking for? 6. So I'm going to take my formula and say to find A sub 6, I keep everything the same except instead of an n, I say I know what position you want. You want the 6th one. So instead of having to, in my calculator, say times 3, times 3, times 3, times 3, I can jump to that position just by plugging into my formula. So it'd be 1 times 3 to the 5th. PEMDAS says do that exponent first. 3 times 3 is 9. 9 and 9 is 81. I think that's 243 if you guys were to actually multiply. And my final answer is 1 times 243. That's how you finish homework. Use this pattern to make a formula. That's your equation. From the formula, make your equation. From the equation, you're going to plug in, I think for that entire section, wasn't it just 6? Yeah. Sometimes you'll have a table. Sometimes you'll have a graph. Sometimes you'll have a sequence of numbers. But you guys know we need to plug into our equation. But have your notes close. That way you don't get lost. All right, okay, so that. Make sure you take a picture of homework on the way out. Number 13 tomorrow. I'll see you guys later.